Good morning, children. Today we will be studying about the order of a reaction, characteristics of order of a reaction, examples of reactions of different orders, and unit of rate constant K for reactions of different orders. First of all, let us start from this one, elementary reaction. Now, a reaction will take place when the reactants collide with each other. If the product formed on colliding the reactants with each other is stable in one step, then such type of reactions called elementary reactions. It means that in one step only such type of reactions give the stable product. For example, the thermal decomposition of ammonium nitrate to give nitrogen gas and water. These two products, nitrogen gas and water, are stable. So this reaction takes place in one step. It is an example of elementary reaction, and the other one is your complex reactions, a chemical reaction in which the colliding species or reactants will not give a stable product in one step, then it must take place in more than one step. Such type to give the final product, a stable product, it is called complex reactions. Another way we can say that in first step, the product formed is called, which is unstable, is called intermediate product. This intermediate product may decompose on its own or may react with the reactants to give final stable product. So those chemical reactions which take place in more than one step are called complex reactions. Let us go for, there are two different reaction rates are there. One is called theoretical reaction rate as per the law of mass action, and the other one is your experimental reaction rate as it is given by rate law. For example, this one, which is your elementary reaction. For this elementary reaction, as per law of mass action, reaction rate is equal to K into molar concentration of NH4NO2 ammonium nitrate to the power 1. And as per rate law, the reaction rate is equal to K into molar concentration of NH4NO2 to the power 1. This one is called the order of the reaction, which we will be explaining it. As per the definition we will go for. So for elementary reaction we can very well see that reaction rate, which is called it as per the law of mass action, which is called theoretical reaction rate, is given by this, and experimental reaction rate is your this. Are they same? Yes, they are same, because elementary reaction takes place in one step. For elementary reaction, the theoretical reaction rate and experimental reaction rate both are same. Now let's go for complex reactions. For complex reactions like this, as per law of mass action, the reaction rate is equal to K into molar concentration of N2O5 to the power 2. Here we see that the power is your 2, but experimentally it is being observed that as per rate law, the reaction rate is equal to K into molar concentration of N2O5 to the power 1. So what is the difference between these two? There is too much difference. Here the molar concentration of nitrogen peroxide is raised to the power 2, which is being observed in balanced chemical equation. But in rate law, it is your molar concentration of N2O5 is raised to the power 1. What can be the reason for such difference? It is being observed that this reaction takes place in 2 steps. Here is step 1. Step 1. N2O5 on decomposition gives NO2 plus NO3. This NO3 is your intermediate product. So now in step 2, and this is your slow step. And step 2, we find N2O5 plus NO3 gives 5 NO2 plus O2. See, 2 plus 1, 3, and oxygen is your 5 plus 3, 8, 6 plus 2, 8. This reaction is fast. We know that slow step is your rate determining step because it takes some time, and for slow step reaction we can easily calculate the reaction rate. But for fast reaction where the time is very less, so it is difficult to calculate the reaction rate for fast reaction. Now as per this one, step 1, as per the step 1, we can write reaction rate is equal to K into molar concentration of N2O5 to the power 1. So the theoretical reaction rate and experimental reaction rate both are different for complex reactions. So I repeat, for elementary reactions, the theoretical reaction rate and the experimental reaction rate both are same. But for complex reactions, the theoretical reaction rate and the experimental reaction rate both are different. In complex reactions, which takes place in more than one step, the slow step is your rate determining step, which is being explained with this example. Now coming to the definition of order of a reaction. It is defined as the sum of the exponents to which the concentration terms are raised in the rate law expression. Here you can see as per the rate law, the reaction rate is equal to K into molar concentration of N2O5 to the power 1. So order of this reaction is 1. Whereas Here too also we can see that order of the reaction is also 1. Now coming to the characteristics of order of a reaction. There are two characteristics. One is the order of a reaction may be 0 or a positive integer or a positive fraction. And number 2 is the order of a reaction is always calculated experimentally and not taken from balanced chemical equations. Now let's go for the examples of chemical reactions having different orders. Examples of reactions of first order. Reactions of first order, that is, the value of n is equal to 1. Let me explain this one first. If A gives products, then reacts as per the rate law. The reaction rate is equal to K into molar concentration of A to the power 1 as per rate law. This is for the experimental reaction. What do you mean by the order of a reaction is 1? It means that if we make the concentration of A, if we double it, then reaction rate also will become double. Take the example, if this one is your 2, then 2 to the power 1 will be what? 2. It means that reaction rate also gets doubled. If the molar concentration of A becomes 3 times, then 3 to the power 1 is equal to what? 3. It means the reaction rate also becomes 3 times. And if it is halved, the reaction rate also will become half. So this means that the order of such reaction is called 1. Examples is your net thermal decomposition N2O5 gives NO2 plus O2. This is your first order reaction. Another one is your ammonium nitrite, NH4NO2 on decomposition gives N2 plus twice H2. Here also the order of the reaction, the value of N is your 1. Then coming to order of the reaction 2 or reactions of second order. Of second order, n is equal to 2. Another, let's take that A gives products. So as per the rate law, the reaction rate is equal to K into molar concentration of A to the power 2. Such type of reactions are said to be of order 2. What do you mean by this? Let us take that if the molar concentration of A is doubled, here A naught, let me explain in this way, A naught is your X. Now this A becomes your 2x. What does it mean? Doubled. Then for this one, reaction rate R naught is equal to K into X to the power 2. For this one, let it be your RT. RT is equal to K into 2x to the power 2. That equals to K into 4x squared. It means that if the concentration of a reactant is doubled, then reaction rate becomes 4 times. Compare it. Compare these two. Compare it. It becomes 4 times. And let us take that at time t1, it is your 3x, then reaction rate RT1 is equal to K into 3x square. That equals to K into 9x square. Now compare with this one. Compare this with this. It becomes 9 times. I hope it is clear. Now, examples of this one is examples of second order reactions are NO2 on decomposition gives NO2 on decomposition gives NO plus O2. So twice 4. Then as per the rate law, reaction rate is equal to K into molar concentration of NO2 to the power 2. So here the value of N is equal to 2. Another example is S2 plus I2 gives twice HI. It means as per the reaction rate law, the reaction rate is equal to K into molar concentration of S2 into molar concentration of I2 is 1, 1. So order of the reaction will be 1 plus 1, that equals to 2. And there is your third order reaction. Coming to zero order reaction. For zero order reaction, what does it mean that? What does it mean? For zero order reaction, N is equal to 0. So let A gives products. So as per the reaction rate law, the reaction rate is equal to K into molar concentration of A to the power 0. And we know that any number to the power 0 is 1. So that equals to K into 1, that equals to K. What does it mean? That for zero order reaction, it is independent of the molar concentrations of the reactants. The examples, all the catalytic reactions are of zero order reaction, because such rate of such a reaction does not depend upon the concentrations of the reactants. Take the example of thermal decomposition of ammonia. Twice NH3 gives N2 plus thrice S2. Here platinum is the catalyst. So as per the rate law, the reaction rate is equal to K into molar concentration of NH3 to the power 0. That equals to what? K into 1, that is K. That is, reaction rate is independent of the concentrations of the reactants. Is it clear to you? Now, coming to Unit of K for reactions of different orders. How to calculate? Let us take an example. Units. Units of K for reactions of different orders. Consider a reaction. Na gives products. As per the rate law, reaction rate is equal to K into molar concentration of A to the power N, where N is what? Order of the reaction. Now, go for K is equal to what? Reaction rate by molar concentration of A to the power N. Is it clear to you? Now it is your unit of K is equal to what? Unit of reaction rate. So what is the unit of reaction rate? Mole per liter per second. And what is the unit of molar concentration? Mole per liter to the power N. The same can be written as mole per liter to the power 1 minus N per second. I hope it is clear. Here is your till here is your to the power 1. So mole per liter to the power 1 minus N per second. Now make a chart. Make the chart. Here is your N, order of the reaction, and here is your unit of K. Consider it. If N is your 0, the order of the reaction is 0. Substitute the values of N is equal to your value of N as 0. Then it will become what? This one will become mole per liter to the power 1 minus 0 per second is equal to what? Mole per liter to the power 1 per second, that equals to, let me write it there. Where to write? If the value of N is 0, then unit of K will be equals to what? Mole per liter to the power 1 minus 0 per second, that equals to mole per liter to the power 1 per second, that is mole per liter per second. So it will be your mole per liter per second. Now, if the value of N is 1, you do the calculation by yourself and find out. You can very well see also here. It will be equals to mole. Here, put the value of N as 1. Mole per liter 1 minus 1 per second, that equals to mole per liter to the power 0 per second, that equals to 1 into per second. So per second it will be per second. Now in the same way you calculate the value, the unit of k for when the values of n becomes 2, 3 and so on. I hope it is clear. Thank you.